Hi, I've got something kind of neat to show you today. The little board you see in front of you there is a Tang Nano 20K, which is running the Nanomig FPGA core, which is a kind of cut down reimagining of the Minimig core. It's currently ECS only. Until very recently it was chip RAM and slow RAM only, but I've since added 4 meg of fast RAM to it. That's what I've been working on recently. The little board in front is I think it's a clone of the WaveShare RP2040, which is running FPGA companion firmware. So it's currently running AMI test kit on that monitor there, and while I was adding the fast RAM to it, and you can see it's detected some fast RAM there, but while I was adding the fast RAM capabilities I needed some debugging, and there is an issue with the GoWin GAO software. It works, but it needs the USB ports configured in a certain way, which precludes using the UART, so you can't use serial debugging and GAO at the same time, and swapping back and forwards is a bit tedious. But you can use OpenOCD at the same time as the serial port, and since I've done a fair bit of JTAG tinkering in the past, I wanted to do the same on this board. So I'll show you that now. Over here I've got OpenOCD running. I've got a configuration file first of all for the Tang Nano, which sets up the USB interface and sets up a tap, which then a secondary script will access, in this case just test. Now what this particular script is doing is setting up a capture trigger. I've got a design running embedded in the Nanomig core now, which basically exposes address, request, acknowledge and so on signals, so that we can monitor them a bit like you would in Signal Tap or any other debugging probe. But anyway, it's currently set up a trigger. It's waiting for the first digit of the address to be a 2, i.e. the start of fast RAM, and then waiting for a RAM request signal. And it's just sitting there because there's no requests happening to fast RAM at the moment. But if I start the memory test running on AMI test kit, just about to hit fast RAM now, and there we go. It's done a capture and it's dumped the results text-wise to the console, and then quit. I mean that's nice, but it's not super useful. There's a better way to do it. So I've also got. Oh, hang on one moment. We have someone passing through. Hello, Sadie. Okay. Oh, she's now going to play with the case of the phone. Anyway, so there's a better way to do it, which is to dump the data to a VCD file, and it's perfectly capable of doing that, dumping data to a VCD and then quitting. But even that, there's still better ways still. Instead of dumping to a VCD file, if you dump to a FIFO pipe, then something quite interesting happens. I'll show you that now. So let's run capvcd.tcl. Now it's just going to sit there because the first thing it does is write out some headers to the VCD file, and that blocks until something starts consuming it. So if I move up to that window and run GTK Wave, there we are. Now what's happened there is that once GTK Wave has started consuming the VCD file, the script has then set the triggers and activated them. Once the AMI test kit came around to accessing fast RAM again, it sent the results back over JTAG. The VCD file got completed and then closed. Now the implication of that is that if I now click the reload button in GTK Wave, the whole process will repeat. So you see it's waiting, and now it's about to access fast RAM on the test. And there we are, it's finished, it's sent the new set of data through. So there we go. I'll just let it come around again, and then I'll click it slightly after it started fast RAM so you can see different addresses being captured. Okay, there we go. So there we go. You see, It's not quite as flexible as the regular GUI probes that you get with the vendor tools, because you have to edit the TCL script to change the trigger criteria. But the advantage of it is that this will work with Intel, Xilinx, Lattice and Go in FPGAs so far, and potentially others in future, so it's not tied to a specific vendor's chips. So there we go, that's what I've been tinkering with recently. I thought you'd find that interesting. That's all for now. Thanks for watching.